Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 19, 2025, just yesterday. This paper shows that when AI research agents generate a more diverse set of model ideas, they reliably perform better, and carefully controlled experiments confirm that this diversity actually causes stronger results, rather than just correlating with them. The paper is titled, "What Does It Take to Be a Good AI Research Agent?" Studying the role of ideation diversity. And as we will see later, the implications for how we design and evaluate research agents are quite significant. Figure 1 shows that agents proposing a wider variety of model ideas tend to win more medals on MLE-bench. Ideation diversity here means how spread out the planned model architectures are, measured using Shannon entropy, so higher values mean more varied plans. Each colored cluster represents a different backbone model, and the upward trend line indicates a positive relationship. The reported Pearson correlation of about 0.57 confirms that this link between diversity and performance is statistically strong. Figure 2 shows what an AI research agent actually does while solving one MLE-bench toxicity classification task. The left tree depicts the branching trajectory of ideas, where each node represents a concrete attempt, and some branches end in failures. The colored boxes on the right unpack one successful branch, walking through ideation, implementation, execution, debugging, and improvement. This layout makes the agent feel like a scientist at a whiteboard, iteratively refining a single research plan as feedback arrives. The figure also illustrates how mistakes in code trigger repair steps, which then lead to stronger models and better leaderboard scores. Figure 4 reinforces that agents which explore more distinct model architectures in their first few ideas tend to win more medals. The horizontal axis shows tree-level diversity, meaning how many different architectures appear among the first 5 draft nodes. The vertical axis shows medal rate on MLE-bench. Points on the right, especially those for O3 and GPT-OS backbones, generally sit higher, which signals that greater early variety pays off in final performance. Figure 6 shows that forcing agents to produce similar ideas clearly hurts their medal rate on MLE-bench lite. The left pair of bars indicates that the AIRA greedy baseline wins more medals than its low-diversity version. The right pair shows the same pattern for AIRA MCTS, so reduced diversity again lowers performance. Error bars around each bar represent statistical uncertainty, which remains small enough that the drops look robust. Overall, constraining ideation diversity consistently makes both agent scaffolds less successful. So while Figure 6 focused on diversity interventions, Table 1 shows how Kaggle medals are actually assigned across competitions. The table summarizes that bronze, silver, and gold thresholds depend on how many teams enter a competition, so the same medal can mean very different percentile ranks. For small contests, bronze can reach down to the top 40%, whereas for huge contests, it tightens to the top 10%. This variability makes medal rate a noisy performance signal for AI research agents, because an agent's apparent success partly reflects competition size rather than true model quality. So the big takeaway is that ideation diversity is not just a nice to have. Diverse model ideas both correlate with and causally improve research agent performance, partly by avoiding repeated implementation failures. More broadly, this suggests future agents should be explicitly designed and evaluated for diversity. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.